Hey guys, this is Mrs. Lehman, and I'm just going to do a quick summarization of what we did in class today when you guys were doing pictures. So some of you came in and out at different points, so I'm just going to start here and just go from there. Just kind of follow along. I'm going to try to make it as quick as possible. We'll see what'll happen. Okay. So just a little review of multiplication. So give me a chance to get my markers and everything ready. Okay, so if Amy has 8 boxes of buttons and there are 63 buttons in each box and we're trying to figure out how many she has in all, that's multiplication. So this is just a 2-digit by a 1-digit. So definitely review from 4th grade, but you're always going to start with the bottom, whatever's in the ones place, and you're going to multiply times the ones and then the tens, and you're going to keep going for however many digits are up top. So in this case, 8 times 3 is 24, regroup the 2, and 8 times 6 is 48, plus 2 is 504. Now that was a pretty simple problem, so now I'm going to make it slightly more complicated. So Amy still has 63 buttons in each box, but right now Amy's going to have 38 boxes instead of 8 boxes. So now we have a 2 by 2. It starts out exactly the same with doing 8 times 3 and 8 times 6. So we're actually going to get the same answer for this very first line because 8 times 3 is 24 and 8 times 6 plus 2 is 50. But because there's 2 digits at the bottom, we have to go one more step. So before we can do that next step, we have to get rid of any of our regrouping, and in our mind we need to think, oh, I'm done with that 8. I'm not going to do anything else with it. So now I have to take this 3 that's in the tens position. And because it's in the tens position, it really has a value of 30. Okay, so because it has a value of 30, our answer to 63 times 30 is going to have a 0 in it. So right there's my placeholder 0. He's supposed to be smiling. That one's a little smudgy. But anyway, so once I put that 0 down there, that 30 turns back into a 3. Okay, so now I have a 3, and I have to multiply it times the ones digit first. So we have 9, and then times the tens digit, which is 18. Notice how everything is nice and lined up here because I want to have that nice and lined up so that I'm ready to do my adding. Okay, so 4 plus my placeholder 0, 0 plus 9, 8 plus 5 is 13, regroup the 1 and 2. So in this case, I have 2,394 buttons. Okay, another example. This one's pretty simple. Sorry. The story is there are 4 groups of skiers, and each group has 41 skiers. How many skiers are there? Well, I only have 1 digit at the bottom, so I'm going to do 4 times 1 and 4 times 4 to get 164. That one I feel is too simple, so we're going to crank this up a notch. So we're going to say, hey, there are now 241 skiers in each group, and there are, oh, let's go 54 groups. This is going to be a lot of skiers, but that's okay. We can handle it. Okay, so for our first step, we have to take that 4 and the 1s, and we have to multiply it times everything up top. So we have to multiply it times the 1, the 4, and the 2. So 4 times 1 is 4, 4 times 4 is 16, and 4 times 2 is 8, plus 1 is 9. So 241 times 4 is 964. Get rid of the regrouping. In my mind, I'm done with the 4. Before I get started, this is really 50, so put my placeholder there. So hold that spot. That one's a little better. And then I have to do 5 times everything up top. So 5 times the 1, 5 times the 4, and 5 times the 2. So 5 times 1 is 5, 5 times 4 is 20, regroup the 2, 5 times 2 is 10, plus 2 is 12. Once again, notice everything's lined up. That's a super important part about making your life easier when you're doing this, especially with paper and pencil. So 4 plus 0 is 4, 6 plus 5 is 11, 9 plus 1 is 10, and then we have 1 plus 2, and a 1 all by itself. So in this case, there's 13,014 skiers. Okay, so there was your introduction on those last 2 slides of what it looks like when we have 2 digits on top and 2 digits on the bottom, or 3 digits on top and 2 digits on the bottom. So now we're going to look at, I'm going to skip this one. We're going to look at something else from 4th grade. In 4th grade, you should have learned about area. And in order to find area, you're going to take the length of a shape, and usually you're talking about a square or a rectangle, and you're going to take the length and multiply it times the width. So in this case, Bob's living room is 7 feet long. Sorry, let me erase a little bit of that. That was a little bit too long to be 7 feet. Okay, it's 7 feet long. and it's 12 feet high. So that's the living room right there, 7 feet and 12 feet, okay? And because we're doing area, that's really like cutting this way into 7 pieces, and then this way into 12 pieces. Oh, I need one more, okay? And we're finding out how many of these little square sections there are. So it's multiplication, it's 7 times 12. So when we do 7 times 12, we end up with 84. Now the important part about area is we're finding out how many squares of space are inside of this. And if I count them all up, there's going to be 84 in here. But our label is important because we're finding how many squares are in there. Our label is square feet. And some of the kids that were in class told me, oh, our fourth grade teacher told us the abbreviation for that, which is a little 2. So when you write feet and the little 2, that's also an abbreviation for square feet. Okay, so the last thing I talked about in class today was decimals, because a lot of people are like, well, how are decimals going to be any different than whole numbers? So here's the rule about decimals. When you're doing a problem with decimals, you are not, absolutely never, ever, ever going to line up your decimal points unless they perfectly line up with how it just gets written. But you'll notice here that our decimal points aren't lined up, and they're not supposed to. And we're not going to annex any zeros either. We just put the number that has the most digits on the top and the number that has the fewer amount of digits on the bottom. So we have 3 digits on the top, 2 on the bottom. And then basically we're just going to ignore those decimal points to get us started, okay? So ignoring those decimal points changes this into a whole number problem, and it's really 362 times 47. So when I solve this, and I actually already did all the work for you guys, but when I solve it, it's 7 times 2 is 14, and 7 times 6 plus 1 is 43, and 7 times 3 is 21, plus 4 is 25, and then cancel out that, and then ignore that 7. We have our placeholder 0, and then 4 times 2 is 8, and 4 times 6 is 24, and 4 times 3 is 12, plus 2 is 14. So there's our second line. Then we just add them all up, and what I end up with is what's down here at the bottom. Now you might be thinking, oh, but Mrs. Lehman, you got a decimal point in your answer. How did you do that? Okay, so it takes us back to, we were ignoring it, but I'm going to put them back now because now we need them. So to solve it, we just ignore them like they're not even there. And then at the end, we have to do a little bit of counting. Okay, so what we do is we look at our factors, our numbers that we're multiplying, and we count how many digits are after the decimal point. So in this first one, there are 2 digits after the decimal point in the top number and 1 digit after the decimal in the bottom number. So we have a total of 3 digits after the decimal point. So according to how this works with multiplying decimals, in our answer, we need to have 3 digits after the decimal point. So I had to put it between the 7 and the 0 so that I have 1, 2, 3 digits after it. And then we need to stop and ask ourselves, is my answer reasonable at this point? So when I look up here and I just look at the whole number part, I see 3 times 4. Well, when I look at this, it's really 3 and 6200ths, which is really kind of close to 3.5, or technically close to 4, okay? And then the other one is 4.7, or 4 7/10, which is kind of close to 5. So really up there, if I was going to round that a little bit, it would be 4 times 5, which is 20. Okay, and so when we look at this, oh, well, if my estimated answer is 20, my real answer is 17 and something, that makes sense to have the decimal point there, because if I had it, sorry, it wasn't supposed to do that. If I had it somewhere else, it wouldn't be reasonable or make sense. If I had it between those, 3 times 4 or 4 times 5 is nowhere close to 1. And if I had it over here, 3 times 4 or 4 times 5, not anywhere close to 170. So it's perfect right there. 17 isn't exactly 20, but it's pretty close since we were doing estimating to figure out the 20. So looking at our last one, I've done all the work for you. I ignored the decimal point and I did 651 times 32. I ended up with 20832. The question would be, where does the decimal point go? Well, I have 2 digits after the decimal point in this one, 1 digit after it in this one, so I have a total of 3 total digits after the decimal point, so I need 3. 1, 2, 3, and decimal point goes right there. So my answer is 20 and 832,000. So let's say, is that reasonable? Well, if I have 6 times 3, so I'm estimating, ignoring the decimal part, 6 times 3 is 18, so it's reasonable to say, oh, estimated 18 is pretty close to 20. It wouldn't make sense for that decimal point to be anywhere else. Okay, guys, that was like a real quick summary. Next week when we have class again, we will be doing more of this. If you want to have a little extra practice, you can go into the C section of IXL and do a little practice there. You don't have to, but I'm saying if you want a little multiplication practice, there's some good activities in the C section. Okay, so have a great rest of your day, and I'll talk to you at our next class.